How to automatically train models and run inference on only the relevant data. Well, we start by automatically identifying what data is relevant. Let's get into it. So here you're looking at a random noise data, which does not have any structure, or in other words, it has a lot of information or no redundancy. Fortunately, for signals that we want to identify, for example, real world sensor data, it has a lot of structure to it because these signals typically capture some signature of a physical phenomena like periodicity in rotating machines or spectral signature from chemicals, materials, or satellite data. Now, this structure, the existence of this structure basically means that there is not a lot of information or there is actually a lot of redundancy in this data. Now, to summarize this, it means that random noise has a lot of information, whereas signals inherently do not have a lot of information. And so ideally, we should be able to design systems that can sample or collect information, collect data according to the information in the signal. Meaning, if you have a signal with more information, collect more data. If you have a signal with less information, collect less data. What this can enable is essentially getting rid of 90% of raw data for a lot of real world signals because they do not carry a lot of information. In fact, Lightscline has automated the identification of useful data by training and running inference on models which are trained on much less data points. So it makes the entire pipeline of sensor AI analysis very efficient. You can learn more by clicking in the description below of how we are leveraging our AI for use cases across satellite data, fiber optics data, vibration data, and so on. I am Ankur from Lightspline, would definitely love to chat more about your use cases and if we can be helpful. Thank you.